So I'm just going to, I thought I had a little bit long for my presentation, so I'm going to skip a few slides. So don't be worried that I'm missing stuff. So I'm just going to try and give you a high level overview of what we're doing. So we have a XULE. It's basically very similar in many ways to XF. It's a syntax, but we use that syntax primarily for querying instance documents and querying taxonomies and taking that data and then all that information and then pulling it together and then producing an output, which is usually today for QC rules in the format of a rule. But we also use it for rendering inline instance documents, for creating instances, and for creating taxonomies as well. So the nice thing about that is that you can use a single syntax not only to check filings, you can use it to do a whole bunch of other things which can be sometimes very time-consuming to do it manually. So just to give you an idea at a very high level, this is kind of more at a document level of how you can process stuff. So the way that XULE is currently written is, you can see it's in the middle, and the things at the top are like inputs and the things at the bottom are like outputs. So this is kind of a lot on here, but this just gives you an idea of what you can do. So you can take taxonomy information on the left-hand side, or you can take an XBRL report, either in JSON format, XML format, CSV format, or inline XBRL format. Then you can run that through XULE, and then you can output primarily what we've been using it for is outputting rules, but you can also output a new taxonomy. You can output an instance through this thing called XINTs, or we can output a inline XBRL doc. We've also found that sometimes people are publishing things in CSV files and Excel and JSON, which they have published in a taxonomy, and then we can also take those. What we're trying to actively promote is that we can get more and more information into the taxonomy because it's just a cleaner model for us to use, but we can also take, the XULE processor can also take data from various sources, and it can also output in various sources as well, not just a taxonomy or an instance document, but also CSV or JSON if you want it. And that comes in handy if people want to bring stuff into Excel and that kind of stuff. So that's kind of like a very, very high level of what you can take in and what you can take out, what you can produce. So just to give you a feel for it, and you'll notice this is very similar to XF in many ways. And what we tried to do when we first started writing XULE was to try and make sure that it was very familiar to people. And so we kind of used the XF spec as kind of it's just a guideline for us. So you can see the same thing. We're still using namespaces. There's still an assertion. You can indicate if it's satisfied or unsatisfied, depending on your result. The way that filters are implemented is slightly different. We try to compact that and make it shorter than XF because, we found that variable. So that's shortened again. And you can see here you got @concept equals assets. So you can define all the dimensions that you need in that filter. So that filter becomes one expression. So we said, that's non-neg. So basically that defines a variable. That'll go and get all the assets in an instance document and give it a non-neg variable, and we can check that it's less than 0. And so in the case above, you can see above there's a very small instance document. And there's two values there that are negative, line 2 and line 4. So if you were to run this rule, it's going to go through each of those rows. It's going to basically iterate over each of them. 4 iterations. It's going to return 2 of them meet the condition. Then it's going to return a message. And you can see you've got a lot of control over the message. You can take a lot of information that you've generated from within the rule, and then you can include that in the message. So you can see here, non-neg, you've got this idea of properties. So you can pull a property from the fact. In this case, we're taking the concept name. Take the period, you can take any basically attribute that the fact has, and then you can output those in a message. So this is gonna produce 2 messages. It just basically does places the variables and then gives you the output. It also will go through and iterate over every single case. So obviously, in the previous example, we saw that there was a dimension on some of those. It's going to run on those as well. You don't have to define stuff for the dimensions. So this runs in a very similar way to what XBRL formula does today. There's not much difference there. So why don't we use XF? So there's some problems when we tried to run XBRL formula, and we're looking at for running DQC rules. And so we kind of had to come up with something that would kind of address those situations. And we wanted to make sure that the language was quick and easy to pull data from instances and taxonomies. We needed both of those. And today, Formula is not so great at pulling information out of the taxonomies. XULE can pull information out of multiple taxonomies at the same time. So we use that a lot for DQC rules. And we tried to use a lot of the existing infrastructure that was there, and so we used it's currently published as an RL plugin, but Altova has also provided support for it in their Altova Raptor product to date. So XULE is used. What we're using it today is we're defining rules, validation rules, and that's for the Securities Exchange Commission, for the Federal Energy Regulatory Commission, the Federal Energy Regulatory Commission, and we also run it on IFRS filings, both for ESEF and for IFRS filings done to the Securities and Exchange Commission as well. We have been using it to normalize XBRL data. So basically, we have run routines for the insurance industry. We're very interested in normalizing data filed to the SEC. So we use XULE to do that as well. So we can basically navigate the taxonomies, pull all this information and collapse it, and then create standard instance documents. It's used to generate inline XBRL documents for the FERC. It's used also to create instance documents, and we're also using it to convert data that's been published out in XML or JSON and in spreadsheets, and convert that into XBRL instances. And this is particularly useful where we have cases where people are reluctant to adopt XBRL. They say, we've got all this data and we're getting everyone to report it in spreadsheets. We can map that in and basically report, turn a large body of Excel documents into XBRL instances very quickly. So it can be used for multiple purposes. And the nice thing about it is you just need to learn one syntax and then you can do all that stuff. So XULE's kind of comprised of these key components. So you can query the taxonomy and instance properties. So if you understand the XBRL specification, we've kind of quantified everything down into properties of every single object. So it's really at an object model level. It's kind of completely independent of the syntax. We don't really have to worry if something's defined in XML or JSON or CSV. Everything's kind of read as an object, and we'll talk about that in a second. The other idea is fact filtering, which we kind of saw with the non-neg example. You can filter things on dimensions, multiple dimensions, some dimensions, then the dimensions later, which is useful. And taxonomy navigation. This is something that is very, very useful. We use this all the time. So this is how you can navigate the taxonomy. And it's kind of similar in many ways to what you'd see in a graph query language. So you can go through and you can navigate all those trees. You can go up the trees, down the trees, go from one tree to another tree. So it gives you a lot of flexibility to navigate not only the taxonomy that the instance is associated with, but you can go and look at other taxonomies at the same time that you're processing it. And we use that a lot. That sounds kind of abstract, but particularly in the SEC where you've got filings coming in, you've got taxonomy, you have no idea what you're going to receive. It's going to come at you. It's the first time you've seen this taxonomy. We can navigate that taxonomy. We can pull information out of it. Then we go and compare it to the US GAAP taxonomy. We see whether they're different, and then we can identify if that's correct or not. Dimensional alignment and iterations. This is kind of similar to the way that Formula works today. This means that it iterates over an instance, it iterates over every context, and then aligns everything. And then you can control that alignment in the syntax. It doesn't use XPath. This is something we deliberately chose to move away from. So we've redefined the mathematical and text operations, data operations, independently, and generally it's based on the way that Python works. If you're familiar with Python, you'll see the way those functions and operations and property works are pretty much identical to Python. We did that because many data analysts are familiar with Python at this point, so it just make it easier for a broad audience. You can define your own functions, like we have an LEI function to check an LEI is correct, check a QSIP's right, check an ISIN's right, check a FIGI's right. So you can do those type of functions in it. You can define variables, both global variables, like parameters in XBRL formula. You can define local variables. And probably the most important thing, probably the most powerful thing, is the management of collections, sets, lists, and dictionaries. And this operates exactly the same way that you can do operations on those things in Python. And that's extremely useful. That gives you so much more flexibility over how you can manage data. And a lot of the rules we currently write today are possible with those features. So I'm going to skip over some of these slides because it goes into a lot of detail. I'm just on those things, but probably worthwhile. Don't expect anyone to remember this, but this is kind of the taxonomy object. So the core model breaks everything down into these components, and then the properties. So these are all accessible from XULE at runtime. So if I open a taxonomy, I can basically access all of those things. And this looks like a lot, but it's really useful. But you could be accessing any of those properties for multiple taxonomies. So you could load 1, 2, 3, 4, as many taxonomies as you like, and then you can access those properties and of each of the components. And obviously, a taxonomy is comprised of concepts, labels, relationships, and you can access any of those. The cube object, for example, we kind of had that as an object. So if you want to give me all the facts in a cube, you can get that kind of stuff, which is kind of difficult today. I don't even think it's possible with Formula, right? So you don't have to go and navigate all the arcs to work it out. So it makes it much, much easier for the user to pull information. So if you say, I've got this cube, give me all the facts in the cube, you can give me all the dimensions in a filing, so that's all there. And then the objects for the instances as well. You got full access to that. So that means you can pull this information. If you've got a fact, you can pull this information on it, pull the footnotes on it, you can pull the entities, the units, that kind of stuff. You will notice here we have inline as separate properties. There's a big debate about this. What happens if it's not an inline document? What happens then? So we have some default behaviors that will happen if you call these functions and it's not an inline document. Basically, everything would be returned as none. But that's probably the only thing in there which is kind of specific to an instance type. But it'll still operate even if the instance is an XML, JSON, or CSV. So in terms of fact filtering, you can basically get access to any information in an instance and all the information that's there. I'm going to go through that. There is the idea of pulling facts back, then you can apply a where clause to it. So this gives you the ability to do more operations on it. And so after a where clause, you can ask, I want facts with a given decimal or specific value, or you can write any expression after it. So you can do a filter, you can pull all the information back, and then you can do further operations on it. So this is kind of what we said. You can filter on a concept. This would be all assets. This is the same as defining like a variable filter like you do in XF. You can get all the periods if you want. You can combine them. So give me all the concepts that are assets of this particular period. And then you can also then apply a where clause to it. So that where clause, you can see it's $fact. That basically will iterate through. It'll get every fact. And then you can perform an operation on it. And that expression after the where clause can be as complicated as you want. Do a whole bunch of other stuff as well. So that's kind of a really quick run through of fact filtering and how that works. So moving on, I should probably just cover taxonomy navigation because this is a feature we use a lot. We probably use more than anything. So this allows you to return concepts. So for example, you can return the concepts in a specific tree. Allows navigation up and down a tree. You can be used to get a list of all the concepts appearing in the balance sheet, for example. If you want to do that, you can just write a navigate expression to get that. And alternatively, it can be used to get a list of monetary instant items that appear in the notes and not on the balance sheet. So you can do that by I want to go to this role, and I want to navigate down all of these other roles, pull out all these concepts, and then you can control what the properties of the concept you're wanting. So here's an example of this. Just an example, navigate the parent-child descendants from the income statement abstract. So this is going to go down the presentation link base. It's going to get all the descendants for every single node after the income statement abstract. It's going to stop when it hits a relationship with a target name of abstract. So this is basically going to return all the concepts on the income statement, but it's not going to get any of the children or any of the descendants of revenues. So you can see here's the expression, and then see that. But there's the revenues abstract on there. Any of the descendants of that element you can get back. But all of these concepts are going to come back, and they're going to come back, and you're going to get them in a set, and then you can do operations on them. So the next kind of feature is dimensional alignment and iterations. So this is kind of basic, but it allows you, if you're going to add current assets and non-current assets together, you would expect that you'd add the ones for 2023, you'd add the ones for 2024. You wouldn't add 2023 to 2024. That's kind of the idea of dimensional alignment. And that's kind of a given whenever you run a formula in any kind of context. But it gives you control over how you can do that. So for example, if we've got dimensional alignment iterations for adding current assets and non-current assets, and we want to check if it's not equal to assets, this formula is going to run 6 times. It's going to run for 2021 for subsidiary 1, 2020 for subsidiary 1, etc., etc. So as the columns, it's going to go down calculation 6 times. So that's kind of powerful, and this is just a general feature of formula, but it does, one of the things that this implies is that calculations will be done where things are dimensionally aligned. And so one of the things we actively try to promote at XBRL US is try and keep, if you got facts and you want to do calculations on them, keep the alignment of them the same. And we actively try to discourage, I've got another property of current assets. These current assets are all in China, and then if you go and stick another dimension on 123, then the calculation is going to give you a different result. So XULE allows you to actually counter for that, but it's preferable not to. But you can then, if you want to do these calculations other ways, you can say on that same data, if I wanted to add, for example, the values, I wanted to get current assets for subsidiary 1 and subsidiary 2, you can write other expressions as well. And what this is doing is saying, go and add the subdimension subsidiary 1 to the values for subsidiary 2. We're not specifying what the concept is, but it'll then go across and it'll add that for every single concept. And then this is checking if it adds to the value that you have for the consolidated entity. So if you were to run this on that data that we had, that would run 9 iterations that would go through for those 3 blocks and run up assets, current assets, non-current assets, and add all the subs together. So that's kind of how that's how the alignment works. And you've got a lot of flexibility about how you can control that. You can take certain concepts and different aspects in and out of alignment as you need to. Right. So functions, these are just aggregation functions. It's pretty standard. That's available. Standard text functions, things like regex and that kind of stuff's kind of useful if you need to do more complicated stuff. So then if you need to, you've got that available. And then obviously the obvious text functions, obvious date functions. You can define your own functions. This is just like how you do it. If you want to, this function add 2 numbers together, variables, what the operation is going to be. And then functions are actually, we do write a lot of functions because there's a lot of operations we've found that we end up doing over and over and over again. And we just define those in a file and we bring those into a rule set. So have to keep defining variables. You can have local variables. So you've got my integer here, that's a local variable, but you can define a constant variable, which means that variable will apply over all the rules that you're running. And I've got this just as a literal value, but that can be anything. It can be an expression. It could be, that variable can be anything that you want, any object, whatever. So that's kind of powerful, so you can have access to that. And what we do, particularly for the DQC rules, we basically will load a taxonomy into a constant. When we run DQC rules, we basically pre-process all the constants in the filing. We'll load that into a server, run it as a server. So then we get a filing, all those constants are pre-calculated, and that really speed up the performance a lot. So it gives you a lot of, and then it's a constant. And we go through and we basically know which constants we can pre-calculate. And there's a lot, like the US GAAP taxonomy. We have a variable, a constant for the US GAAP taxonomy, for example, and that can be preloaded, and then you can preload a whole bunch of other constants that are not going to change from filing to filing. So we take advantage of that just to make performance better. And finally, management of collections. So we have sets, lists, and dictionaries, and all the kind of operations you would expect on those. So you can do things like into this section of two sets, which can be used, which is really useful if you, like, for example, if you're doing data normalization, you might want to, hey, I've got all these concepts from the revenue statement. I've got these items for a node. I want to create I want to see which ones are common between them. So you can use intersections for that, or union, or get the difference of two sets. Dictionaries obviously can be really handy as well. So you can keys and then match those up and create lookup tables. And then obviously do basic functions on sets and test the properties of collections as well. And you can turn dictionaries, for example, into JSON, and you can output those as JSON files if you wanted to. And collections, a set can contain other sets, or a list can contain lists of lists, so you can build up 3-4 multi-dimensional models as well that you may want to use. So, questions there. How much time have we got? Oh, we've got 5 minutes. We can stop for questions. If you want to know more, just so you know, there's a lot of stuff up on the website. And then I'll put this presentation up. It's available. There's more on here. We have a whole bunch of other stuff like Zints, which is how to create instances, how to create taxonomies, and how to create inline documents. And so if you're interested, please let me know. And there's some examples in these slides if you want to download.
Any questions?
So now the programmers on the RIS can make discussions whether semicolons or static typing or dynamic typing. We can throw each other out of the window over these kind of non-important things. But what I really am interested in is the processing model. So I'm really enthusiastic about the capabilities. But I do still see, similar to the formula processing model, is, well, you just have to have everything in memory. So yes, these global constants help a lot, surely, but so for example, given a CSV instance, are there any attempts to try to have some sliding window over CSV to make the processing model aware that it should not load all data but stay in a region? Or so, is there any thought being spent on this in the context of XULE?
Yeah, we've spent a bit of time where this is kind of the next version. We've worked on, like, how do we define formulas for processing large data sets? And we actually have the same term, like a window, like we have a processing window. How do I define a window? How will I process that? How do you define what a window is? This idea of aggregators, so that as I'm going through all these, I may want to set up an aggregation window so I can aggregate stuff. So I don't have to load the whole file, but I'm keeping certain variables in memory, not every single transaction. And then the idea of how can I calculate across a transaction. If I've got a transaction record, how can I do? We haven't published that. We're still working on it, and so that's something we're kind of doing more as a feasibility study. But that's something we're going to have to address in the next 3 to 4 months. Question.
Any other questions? So I'd have one comment. The taxonomy navigation functionality that you were showing us, as I understand it, use that both to validate that the extension taxonomies are as they should be, but also to reduce the rules maintenance by using the base taxonomy to derive particular rules.
And we gave a presentation earlier on creating relationships, new relationships, and so we spent a lot of time. Initially, you have to go through and you create a separate list. And that's why on that first slide, you can see we had JSON files. We actually have JSON files which provide lists of elements, and CSV files that provide lists of elements that we use for validation. We're trying to get away from that and then try and push that back into the taxonomy. So obviously we want to try and get all the metadata in the taxonomy that we can. And then the rules can basically point to that. So if an element's deprecated, we don't have to go and update lists and maintain data outside taxonomy. So having a lot of these other relationships, which allows us to, like if we know what's coming in and out of cache, we can say, hey, these are all the inputs and these are all the outputs of cache. I can union them, and I can say any of these items, these are cache items. If any are on the income statement, the balance sheet, it's an error. So it's just really trying to drive down the maintenance costs of maintaining rules.
And to address the earlier question about filing rules, to validate extension taxonomies, also means that a whole additional class of filing rules can now be used as will be formula in the future.
Right.
Rules.
Yeah, the filing rules that we can't, basically anything that's at the XML syntax level, we can't, we really don't have access. We've deliberately not put access to that into the model. So there will be some things which probably have to be done, if they've got a rule that says, if you're filing an XML and it's got to have, it can't have this character in it, in that syntax, then obviously we can check. If it's in an object, then we definitely.
But we've been saying for a while that if you can't access that kind of information from an OIM model or from XULE or from OIM formula rules, then don't write rules about it. You probably don't need them. Worry about your content rather than worrying about the syntax.
Right.
Filing rules will converge towards what the capabilities of languages like XULE are able to do.
It's very tempting to do it, but we've tried not to.
Yeah.
Yeah.
Okay, so please join me in saying thank you to Campbell